Assalamualaikum. We welcome back. So now we are going to start to discuss about chapter 3. So the title for chapter 3 is Electroanalytical Techniques. So at the end of this topic, you should be able to explain the principle of each of the electroanalytical techniques, including three electrochemical cells. Okay, first we look at the introduction of electroanalytical techniques. Okay, look at this flow chart. Okay, so the electroanalytical methods or techniques can be first divided into two major parts. Okay, one is bulk method, another one is interfacial method. Okay, look at this. The electroanalytical methods can be divided into two. One is the bulk method. So you look at this first, bulk method. What is bulk method? So bulk method is the measurement. Okay, let's say we have two electrodes. So one is anode, another one is cathode. So you are going to measure the resistance of the solution in the bulk solution. This is bulk solution. Bulk solution. So you are going to determine the resistance of the solution, Rs. Okay, so in this case, the measurement is to find the resistance of the solution. Once you get Rs, so you are going to convert, the system will convert to current, or we call it capacitance. Okay, G, or also you can find conductivity of the electrolyte here in the bulk solution. So first, it will find the resistance of the solution. What is the ohm of that electrolyte? So once you got the ohm, it will convert to capacitance, or also you can find conductivity, specific conductivity of that electrolyte. All right, that is called conductometry. So G is the capacitance is inversely proportional to resistance. Okay, conductor, it means conductivity. Metry means measurement. Okay, you are measuring the conductivity of the bulk solution. So the application of this method is in titration, conductometric titration. All right. So we are not going to discuss this in details. Okay, but it's just to show you the different. There are two methods, major methods. One is bulk, another one is interfacial method. So how about the interfacial method? Interfacial. Interfacial means that, okay, you know, you have the electrode, the solid electrode, for example, anode, and another one is cathode. Okay, so in this cell contains the solution. So for the second, this methods, the measurement is carried out at the surface, at the interface between the electrode, the solid material here, and the electrolyte. This is the electrolyte, this is the solid electrode, for example, anode. So what is actually happening at the interfacial? Interfacial between the surface of the electrode and the electrolyte. Okay, but in bulk method, what is actually happening in this bulk solution? Interfacial between the electrode and the electrolyte, either at the cathode, at the anode, or the cathode. Here, okay, will be measured. So under interfacial method, it is separated into two more. One is static method, which does not involve current. Current is zero. Okay, so and another one is dynamic method that involve current. Current I, capital letter I, current is greater than zero. This does not involve current, but this involve current. So under static method of interfacial method, it has one technique which is called potentiometry. Okay, what is being measured is the potential difference, okay, between the anode and cathode. What is the difference between this and this one? Okay, so we will get the potential difference between anode and cathode. So it does not involve current. So the application of potentiometry is in potentiometric titration. However, under dynamic method, which involve current, so there are few more methods for electroanalytical methods. It can divided into two more methods, sub-method, which is you just control the potential. Potential is V or E, V constant. Okay, just set one uh, constant potential. Okay, V constant, or we call this potential static. Okay, potential static technique, which static means it doesn't move. Okay, the potential is constant. The second one is galvanostatic. Galvanostatic or amperostatic is they are the same. Okay, which meaning that the current is constant. I constant. Right. So under V constant or potential static, there are 1, 2, 3, and 4. 4 methods. Okay, one is measurement of colorimetry. Okay, you are measuring Q. Q is unit is column. So the name for that particular method is colorimetry. Metry is measurement. Column is the unit or the charge pass during the electrolysis. So the second one is voltammetry. That involve volt and also ampere. Voltammetry. Metry is measurement. It will measure volt, E, voltage, and also the current. Amperometry is the measurement of current. Ampere is current. So electrogravimetry, it involves measurement of mass. Gravity involves electrochemical reaction, electron transfer, and also gravimetry is the mass of the reaction, the reacted mass reacted in the electrochemical reaction. It involves Q equals to M and F. Here M contain the mass of the reaction involved. Under I constant, okay, there are two. Colorimetry involve Q, the column, and also the mass, the electrogravimetry. Q equals to M and F. Okay, so again, you have learned this. Q equals to IT. Okay, I hope by now you understand that there are two, for electroanalytical methods, there are two types. One is bulk. What is bulk? You are measuring the bulk solution. Okay, so the name of the technique is conductometry. Another one is interfacial. Why they are separated, bulk and interfacial? Because the reaction occur for interfacial occur at the interface between the electrode, either anode or cathode, with the solution, with the electrolyte. So under interfacial, there are a lot more potentiometry, which does not involve current, and the others involve current. Okay, for example, colorimetry, voltammetry, amperometry, and electrogravimetry. There are two types: potential static or V constant, potential constant, or galvanostatic or amperostatic, which I or current is constant. Okay, look at this, the explanation for each technique or methods. Okay, what each of these method measured. Okay, so for example, potentiometry, measurement of potential difference. Okay, between indicator electrode and reference electrode. Two electrode potential stat to determine the concentration of analyte or unknown. For example, the application in pH meter. Okay, beside that, you also can do this titration, potentiometric titration, acid-base, redox, and precipitation. We will discuss this later. Okay, next topic. Okay, you are going to plot E, okay, a graph, E versus the volume of titrant added for potentiometric titration. Next one, under interfacial method, okay, which involve current, voltammetry. Okay, the technique is used to observe current, I, okay, ampere, and also voltage, volt. Voltammetry. okay, during electrochemical processes in order to determine the concentration of analyte. For example, especially for metal cation, okay, it's good to determine the amount of metals in your sample, in solid sample, in liquid sample, okay, you can use this voltammetry, okay. So because the current you have measured is directly proportional to concentration of the unknown or analytes. So we will discuss two sub-method under voltammetry, which is polarography, or also known as dropping mercury electrode, as well as cyclic voltammetry. So you are going to plot current versus potential. Okay, so this now involve current voltammetry. Next, amperometry. Okay, measurement of current. Again, current involve current between two electrodes and given applied potential. So the application of amperometry is in amperometric titration. You are going to plot I versus volume of tetran added. Okay, this is the application of amperometry. Next, colorimetry. Okay, colorimetry, the chemical analysis or electroanalysis is based on the charge pass, the Q, column. Okay, Q is equals to I times T, ampere times time, second, during electrolysis. So there are two types, either potential static V constant or I constant, galvanostatic analysis. Next is quite similar, these two, but this electrogravimetry involve the weighing process or the mass, the amount of mass dissolved or deposited. Okay, it's quite similar to colorimetry because it measures Q, column, but it involves additional step which is weighing process. You will weigh the electrode before and after, then get the difference. Okay, next this is conductometry, the measurement of conductivity. So this is under Buck method. And the rest, all this under interfacial method. Interfacial method. But only this under Buck method. Why Buck? Because you are measuring the resistance of the electrolyte. Okay, of the electrolyte. Okay, so once the system measure the resistance of the solution, it will do the mathematical operation, okay, by converting R into G, the capacitance or the conductance of the solution. From conductance G, you can find K or specific conductivity of that solution or material. Okay, so we are not going to focus in detail about conductometry. We are going to focus more on potentiometry, voltammetry, colorimetry, and electrogravimetry in this course. Okay, next, you look at this. Actually, there are two type of potential state. One involve only two electrode, another one involve three electrode. Okay, so for two, especially for potentiometry, conductometry, it involve only two electrode system. Okay, so you just need two electrode. So in this beaker, it contains electrolyte. Okay, so this is the indicator electrode or working electrode. Another one is reference electrode. So for potentiometry, just involve two electrodes to measure the potential difference between here, indicator electrode, and reference. So you will get delta E or potential difference between the two electrodes. That is for potentiometry. But for the rest, okay, voltammetry, amperometry, colorimetry, electrogravimetry, you should have this three electrode system because the rest involve current. Here, potentiometry does not involve current. So you need one more or additional electrode which is counter to measure current, ampere. Okay, so it's quite similar to potentiometry, just involve reference and working or indicator. But for the rest, other electroanalytical techniques such as voltammetry, colorimetry and electrogravimetry, you need one more electrode to measure current here. Okay, so you must add one more, which is counter electrode. So in 3 electrode system, it has reference electrode, counter electrode to counter what is happening at the working electrode. Another one is working electrode. So the measurement of the analysis all occur at the working electrode. For example, indium tin oxide. This is conducting substrate or electrode. Can be used to do the analysis. Okay. So in this cell contain electrolyte solution. Electrolyte and electrode, solid electrode must be present. Okay. So all the, for voltammetry, for example, the measurement is occur at the interface. There is interfacial methods. But for conductometry, it involves in this, the bulk solution. I hope now you can differentiate between bulk method and interfacial, as well as 2 electrode and 3 electrode potential state. Okay, so in order to measure current, you must add one more, and it will have 3 electrode system. Okay, so look at this 3 electrode potential state. One is working. What is the function or the role of working electrode? It acts as a source of electron. If source of electron, it called a cathode, or it also can act as anode, a sink of electron for exchange with molecule in the interfacial region, and must be an electronic conductor. Okay, the working electrode can be cathode or anode, depend on the reaction. If you want to do reduction, your working electrode will be cathode. If you want to do oxidation, your working electrode will be the anode. Next, counter, or also known as auxiliary or secondary electrode. Okay, you can use either counter electrode, auxiliary electrode, or secondary electrode. What is the function? It must be an inert metal. Inert means it does not involve in the reaction. Okay, it's just a site for the reaction to occur. If this is cathode, so the counter will be the anode. If the working electrode is anode, the counter will be the cathode. Okay, so it will counter the reaction, but the measurement occur at this. All the measurement will be taken at the working electrode. This just counter. What is the process? If this cathode involve 2 electrons, the anode also, the counter also must involve 2 electron reaction. Okay, but it must be inert material. Okay, for example, normally they use platinum or carbon. Okay, graphite. Okay, so next, the third electrode is reference electrode. It's used to complete the measuring circuit. Okay, the purpose or the function of this electrode is to complete the measuring circuit, and it should provide a stable, okay, this is the characteristic of the reference electrode, stable and reproducible potential, a well-known electrode potential against the indicator of working electrode is compared. Okay, so must be stable, the value must be stable, and the must be reproducible. Every time you repeat, you will get the same value. If there is no, it's not reproducible potential or voltage, it is not suitable to be the reference electrode. Okay, now we look at the reference electrode. Okay, so the first invented reference electrode is standard hydrogen electrode. So the value is 0 volt. So the standard table, reduction potential table, or the EMF series, all the values of E all against this standard hydrogen electrode. Okay, known as normal hydrogen electrode. It can be anode or cathode. Okay, the reference. Okay, so this is the reaction for SHE, standard hydrogen electrode. This is hydrogen evolution reaction occur at the platinum. Look at this image of photo. Okay, so this hydrogen, okay, this H plus, the ion in the solution, if it is reduction, it will produce hydrogen gas. This direction. Hydrogen plus will accept 2 electrons and evolve hydrogen gas. It occurs at the platinum inert surface. Okay, since there is no solid in this reaction, this is aqueous, this is gas, so you need a site, okay, to do the reaction. The most stable, suitable is platinum, which is very inert, or gold, or also you can use graphite, okay, for this reaction to occur. If the oxidation process is the opposite, okay, hydrogen gas will be bubble constantly into this reaction, into this solution, so it will produce hydrogen plus 1 molar of hydrogen ion. Okay, so the value for this standard is 0 volt. Okay, 0 volt. The problem with this is very difficult to be fabricated or to be prepared. Okay, so that's why the alternative reference electrode constructed. Okay, so and the most common used electrode in the laboratory is the silver chloride electrode. So this is the reaction. Okay, now the material in that reaction is different, not hydrogen, but the silver chloride and silver. Okay, so you look at this, the value, if you look at the standard reduction potential for this reaction is 0, positive 0.22 volt versus SHE. So, but in order to prepare this reference electrode to be used for the lab analysis, so you must prepare a saturated calomel, not 1 molar. This is 1 molar chloride. Okay, in this reaction there is concentration of chloride ion. So this for this standard is 1 molar. Okay, for standard condition 1 molar ion. But in order to prepare, okay, that reference electrode, you just prepare a saturated chloride. Okay, ion. So when you do the stirring or the preparation, the saturation process, so you will get the highest chloride concentration is 2.86 molar. So it will be recalculated. Okay, so you must use Nernst equation. So this is the standard. Okay, 0.222 here. So then it just involve 1 and here 1 electrode. So if you look at this, this is the products, chloride, as well as the silver solid, and at the bottom is also silver. So solid is 1. Ignore the silver and silver chloride. So what does concentration affect the E cell is just chloride concentration. So instead of put 1 here because it's not at standard, so you just put 2.86 molar. Okay, so you will get a new value. Okay, so for lab analysis, you must use this value. You will get this 0.1985 volt. Okay, so whatever value versus SHE, you should consider this. Okay, if you use different reference electrode. Next reference electrode is the saturated calomel, another type of portable or electrode, reference electrode can widely used or commonly used in the laboratory. Okay, but now is calomel. Calomel contain mercury. Okay, so this is mercurous chloride. Okay, will undergo the reduction process and reduce to mercury as well as chloride. Again, this is liquid, this is 0, this is solid, this is also 0. So only one, okay, species that will affect E cell, which is chloride. Okay, so you can recalculate the value if there is at standard, if this is 1 molar, so the value, if you check the standard reduction potential table, the value is 0.27 or 268 versus this is the standard reference electrode, standard hydrogen electrode. But if saturated, So the chloride ion is now 2.86 volt. So you do the calculation similar to the silver chloride. So you will get a new potential, which is 0.241. Okay, now the composition or the chemical compound or the reaction is different as if compared to silver chloride. So the value is also different, 0.241. Okay, for silver chloride, 0.195. Okay, so this is the standard. This is the actual. In the laboratory, during the experiment, you must use this value. All right, so it has this mercurous chloride, it has mercury. Okay, so inside this contain the saturated carbon, KCl. Okay, so you will calculate using Nernst equation to check what is the E here, E reference. Okay, E reference. So E reference here is 0.241 volt. Compare with the the reaction, the working. This is working. So this electrolyte. So this is reference. So you will get the difference between working electron and reference electron. Okay,